Hello and welcome again to CHeM In 3. In today's episode, we focus on this worked example. 25.20 kilograms of calcium chloride is dissolved in 100 liters of water, and you're required to predict the temperature change in the container if the enthalpy of solution of calcium chloride is positive 3.90 kilojoules per mole. Most students would say you have to use this equation. Q is equal to M multiplied by C multiplied by delta T, the change in temperature. But if you're a student preparing to solve this type of problem in the exam, it is certainly not sufficient to simply say that you know this equation and that you can solve the problem, because several issues can arise if you do not actually practice solving these problems. And today, we look at three specific issues that are faced by students in solving these problems. First of all, what mass should you use in the equation Q is equal to M multiplied by C multiplied by delta T? What is the M? Is it the mass of the calcium chloride? Or is it the mass of water in the container? Students are not aware that the value for Q is kilojoules per mole. So you would need to find out how many moles are involved. And finally, which C should you use for the specific heat capacity? The specific heat capacity of water or of calcium chloride? One way to visualize everything and to help you get around these problems is to draw a diagram like this. And here you can see that 25.20 kilograms of calcium chloride, that's being dissolved in this 100 liter container, which is equal to 100 kilograms of water. And here, as this is dissolved, the temperature change is happening inside of the container. So the equation M multiplied by C multiplied by delta T, the change in temperature, it's all related to what's happening in the water. As this number of moles gets dissolved, the heat released is released into 100 kilograms of water that has a specific heat capacity of 4.18. And with this visual, it becomes easier to solve the problem. As you move into solving the problem, note that the enthalpy of solution of calcium chloride is 3.90 kilojoules per mole. So it means that if you have 25.20 kilograms of calcium chloride, then you must divide this mass by the molar mass of calcium chloride in kilograms, and this would give you a value of 227.03 moles. And since the Q value, or the heat lost or gained by calcium chloride as it dissolves in water, the enthalpy of solution, is given in kilojoules per mole, then if you have this number of moles, then the actual energy lost or gained would be 885.4 kilojoules. Putting everything into this relationship where you've now solved for Q, and you know that mass M is the mass of the water in the container, C is the specific heat capacity of water in kilojoules per kilogram per Kelvin, and delta T is the change in temperature which you're trying to solve for. This particular reaction has been stated as an endothermic one, and the value for this enthalpy of solution has been given with a positive sign. So it means that the system is going to take energy in from the surroundings, making the surroundings colder, because this is the nature of an endothermic reaction. And the system gains energy as the surroundings loses energy and becomes colder. So to solve for this temperature change, you need to manipulate this equation and to make delta T the subject of the formula. Delta T is usually given in Kelvin, but the answer could be given in Celsius since it's the change in temperature. So a change of 2.12 Kelvin would be the same as 2.12 Celsius, because the conversion of Kelvin to Celsius is simply a matter of adding 273. Solving for delta T, we make delta T the subject of the formula, and then we solve this equation, and the answer comes to 2.12 degrees Celsius or 2.12 Kelvin. The positive sign symbolizing that the reaction is endothermic and that the system gains energy and the surroundings loses that energy and becomes colder.